2025, because nowadays you are knowing that due to various climatic condition and various biotic and abiotic condition, there is drastically increase in the quality and quantitative food in various sector. It may be pulses, it may be cereal, etc. But what is the major thing? It may be due to the man-made activity, it may be the pollution, it may be the type of drastically we are enhancing this globalization. They are directly, indirectly affecting this ecosystem, and because of that there is a scarcity of the food, scarcity of the water, and it is very difficult scenario by 2050 to feed this large population. So normally you are knowing that if we talk about the particular crop, there are two various factors, that is biotic and abiotic. So nowadays if we see both are affecting very severely because of this climatic condition, and it is we have to take various steps for the sustainable agriculture to minimize the impact of this loss which are creating due to the biotic and abiotic factor. So in this scenario, we can use various biological this biotic abiotic data as an source that can be trained to the different device that can sense and predict whether there is change in the abiotic factor in your field, or where there is drastically coming new biological factor as an pest in your field. So if we see an example, insect pests, these are the major contributor to the agriculture, where they are directly or indirectly affecting the yield and quality of the food. So first one is disease, second one insect, weed, and there are various other parameters also. These are the example of various crop where a huge damage of yield in terms of yield and quality has been noted, and the yield you can see that in case of cotton it may be up to the 50%. So biotic and abiotic factor directly indirectly they are drastically changing the yield and quality parameter of various crop. So what are the different insect which are affecting as a terms of biotic in various crop? So there are different category like sucking pest, beetle, caterpillar, grasshopper, aphids, whitefly. These all are affecting crop in Asian continent or in European continent. So you can use this AI technology to design some equipment that can sense whether the new disease is coming in your particular area. So what could be the parameter? So parameter can be considered as an pheromones that are normally volatile compound which are released by either insect or plant, that can be used as a sensing device. And whatever the data literature we have published till now in the research paper or in scientific literature, that can be used as a reference data, and that can be used to prepare some device. So what are the impact of insect damage in crop? So you are knowing whenever there is a biotic abiotic factor, especially if we talk about the biotic factor, it reduces the yield, it decreases the quality of the particular crop product, and it also increases the production cost, like post harvesting issue. Recently you have seen that in Japan they have rejected the mango batch. Why? Because of the fruit fly. So they are why foreign or European country are taking this type of step, because they are knowing that if by chance that particular pathogen is enter into their environment or ecosystem, it will start adapting in other crops, and once it is adapting, then it will breed in the surrounding, or you can say sustainable that particular atmosphere, and it will cause a major issue in later on. So what control measure? Normally control measure we are taking use of different pesticide, and this pesticide directly indirectly they are creating a major issue. You are knowing about the soil health program, many heavy metals and many recalcitrant compounds which are present in the pesticide. They are directly or indirectly affecting the productivity of the crop, and they are also entering into the different food chain and food web, including human also. And they are also affecting the one of the major player of maintaining this ecosystem, that is honeybee. So if we see the timeline of contribution of biotechnology in the pest management, there are various approach we have done. First one was flavor saver tomato, there is RNAi technology. After that, we have developed various BT variety. Then we have done CRISPR-Cas, and nowadays we are more focusing on gene drive technology. So molecular, now why we are emphasizing on molecular techniques, and this molecular technique can be directly, indirectly used in your AI based driving tools to detect either the biotic factor or abiotic factor present in your system, and it will also help in predicting whether a particular type of pest is arriving in your upcoming climatic condition or not. So we can build different mathematical and statistical model where different parameter, like including type of plant which are susceptible to that particular host, pathogen. Then what are the different you can say carrier of that particular pathogen. So this type of all different data can be clubbed together, and you can predict the mathematical model, and that model will help you to give that whether this type of disease can be it will be shown in your upcoming field or not. So the major important thing is advancement in the insect genomic and transcriptomics. Normally, you are knowing that we are more emphasizing in genomic and transcriptomic data of plant, but nowadays government is also, even especially ICAR is also focusing to go for the genomic and transcriptomics data of insect, because there are limitation of pesticide. You are seeing in the data in field that many insect are showing the resistance against various pesticide. So you have to decode, or you can say you have to go for the data mining of genomics and proteomics and transcriptomics data to identify the potential pathway where you can minimize the population of that particular insect. So conventional method, if you see the conventional method for the insect pest management, this is tissue culture technique, where we are growing this you can say somaclonal variant varieties, or you can say we are using this rDNA technology. We are growing different GMO crops, then bio nano agents, microbial agent that we call as phytochemical compounds, either from the bacteria, or you can say either from the plant, that can be used as a biopesticide. Then sterile insect technique. So these are the various conventional technique, but there are various limitation of this conventional technique. So more emphasis has been given on the molecular part. First one is the genetic engineering technique. So normally you are knowing that in genetic engineering technique, you are taking the DNA from the other species and inserting into another species, or you can say you are cross making barrier, and there are various parameters that can be like transfer that particular gene into the different insect for various purpose. It may be the endotoxin protein, it may be the core protein of virus, it may be the enzyme, etc. So there are a number of transgene that can be used as a target gene for different target insect. So here you can see, if you see the one of the most commercial example of BT toxin, that BT toxin once insert into the gut of that particular insect, it gives the osmotic pressure, and it is disturbing the gut of that particular insect, and ultimately the cell is lies and death. So what are the different transgenic plant that can be that has been developed for using this BT toxin? So BT toxin has been developed for Cry1AC, Cry2AB. So Bolgard 1, Bolgard 2, Bolgard 3. There are different Bolgard, and they are targeted against different type of pest for that particular crop. For example, if we take BT cotton, so Cry1AC, Cry2AB toxin from Bacillus thuringiensis, and the target pest are cotton bollworm, pink bollworm, tobacco, budworm, etc. So these are the specific crop, their gene pyramiding. Now, what is gene pyramiding? Normally, the people from the breeding background, they are knowing gene pyramiding. मतलब आप एक से ज्यादा जीन को एक साथ लेके जो नॉर्मल ब्रीडिंग मेथड है उसके थ्रू क्रॉप के अंदर इंसर्ट करते हो. सो नॉर्मली इन जीन पिरामिडिंग आप 3 से 4 डिसीज रेजिस्टेंट जीन को एक साथ एक क्रॉप के अंदर इंसर्ट करते हो. दैट वी कॉल्ड एज जीन पिरामिडिंग. तो यहाँ पे नॉर्मल ब्रीडिंग टेक्निक को यूज किया जाता है. एंड यू कैन सी द एग्जांपल दैट इन कॉटन, rice, wheat, soybean, etc., where more than 2 gene has been inserted using this gene pyramiding technique. Second one is RNA interference. In RNA interference, this is one of the most classical example of gene silencing, which is natural phenomena of eukaryotes, and in this RNAi technology, you are targeting the expression of particular protein of that insect, and because of that crucial protein, the insect metabolism get disturbed or their biology get disturbed, and ultimately it help in showing the resistance in that particular crop. So here you can see the different example using this RNAi technology for the insect pest management. Like one of the most common example is cotton bollworm helica amigi, that is HRT molting hormone, one of the important hormone that is responsible for different stages of insect that reduce the larval survival, impair molting and metamorphosis. And this experiment has been done in Nicotina tabeca. So genome editing. Now, second parameter is CRISPR-Cas. That is one of the most important tool which we are using nowadays. CRISPR-Cas technology is a revolutionary technology that is used for genome editing that enable to go for the precise nucleotide manipulation, or you can say the creation of SNP in the insect genome. So this technique allows researcher to introduce specific mutation knockout gene and insert new gene into the insect genome, providing a powerful tool as an pest management. So genetic modification, gene drive system, resistance management, these are the basic approaches. So in CRISPR-Cas, you can see there are different target genes, that is phenotype related gene, metabolic related gene, segmentation related gene, insecticide resistant gene, pheromones gene, and male related gene. So these are the different sector where CRISPR-Cas can be applied, and resistance mechanism, or you can say insect pest management, can be developed. So next one is gene drive approach. Now, gene drive approach is one of the most important and recent technology. This has been done under clinical trial by United States of America in, I think so, 2022 and 23. So gene drive refer to the genetic engineering technology that enable the rapid spread of a specific genetic trait through a population. So this is achieved by using the CRISPR-Cas9 gene editing to introduce the desirable trait into an organism genome, along with a drive mechanism that bias the inheritance of the trait. So in simple language, it is modification of the gene desired to spread throughout that particular population with a normal inheritance rate. So here you can see these are the various recent studies which are focusing that gene drive technology, CRISPR-Cas technology, RNAi, etc. are used as an IPM management in different insect and pest. So what are the advantage of this technique? So transgenic crop offer enhanced yield, pest disease resistance, and improved nutritional content, and greater resilience to environmental stress, contributing more suitable and efficient agriculture. So staking of multiple gene, that is gene pyramiding, has increased the protection power against multiple harmful organisms and had added the advantage of durability and reduce the risk of emergence of new pathogen resistance. So RNAi pest management technique are used to identify the target gene of insecticide resistance and also improve our understanding mode of action of insecticide and molecular mechanism of insecticide resistance. So gene drive mechanism of CRISPR-Cas target the gene of interest, which causes either functional abnormality or sterility, and that can be passed to all the different generation that is more faster than Mendelian inheritance. So silencing of the gene confer the resistance against insecticide by using this CRISPR-Cas will enable to use the same insecticide which already got resistance in the field. So these are the different case study I want to highlight. I will not go in detail, but I want to just show that this case study show the identification of novel target gene of RNAi that is mediated in fall armyworm. The people which are not from the core agriculture background, I want to just highlight that fall armyworm, one of the major insect of Spodoptera that we call as Spodoptera fugipera, and it was identified, I think, in 2018 in maize. And nowadays it is showing in many crop like sorghum, rice, sugarcane, etc. because it is polymorphous in nature. So here you can see that RNAi this technology has been applied and the gene suppression has been seen when they have done this trial. Second is insecticidal effect of transgenic maize BT Cry1AB, BT PY3A, and BT Cry1AB plus VIP3A. These are the combination of different gene against different insect, and they are insert into the particular crop as a gene pyramiding example. I will not go in much detail because it is technical part. So I want to just show that this paper is showing that whatever the transgenic approach they have used using this gene pyramiding in crop, they are identifying जितने भी जो जीन है वो एक्सप्रेशन पे प्रोटीन को क्वांटिफाई करके बताया गया कि अलग अलग टाइम इंटरवल पे इस प्रोटीन का इतना क्वांटिटी देखने को मिला है. Next example is population suppression with the dominant female lethal gene. This is an example of gene drive technology. तो यहाँ पे आप देख सकते हैं कि normally Drosophila melanogaster, one of the most ideal you can say insect which used for classical and basic experimental study. यहाँ पे उन्होंने एक लीथल जीन को इंसर्ट किया फीमेल के अंदर और मेंडेलियन पैटर्न के बेस पे उन्होंने देखा कि मोस्टली जितने भी आगे की प्रोजेनी आ रही है वो स्टेराइल आ रही है. So here I want to just highlight that I have given different example, चाहे वो CRISPR-Cas हो या फिर जीन ड्राइव टेक्नोलॉजी हो. मैं क्यों इसकी बात कर रहा हूँ? This is one example. In I think so December 18, 2005, ICAR has initiated genome editing. So government is more giving focuses on genome editing rather than transgenic plant. Here you can see total 17 horticulture crop has been like initiated, and this is a website of this project, that is ICAR genome editing. The more detailed information for different crops can be visualized using this site. So why I'm focusing on genome editing? Why government is not giving more emphasis on GM crops? So normally अगर आप genome editing की बात करते हो, genome editing is easy कंपेयर टू जेनेटिक मॉडिफिकेशन. अगर हम जीनोम एडिटिंग की बात करते हैं तो आपको कहीं बाहर से जेनेटिक मटेरियल इंसर्ट नहीं करना पड़ता, उसके अंदर ही जो जेनेटिक मटेरियल है वहां पे फ्यू न्यूक्लियोटाइड का वेरिएशन क्रिएट करना पड़ता है. सेकंड थिंग इज फॉर द अप्रूवल, टेक्निकल अप्रूवल की अगर बात करें तो जीनोम एडिटिंग की अगर हम बात करते हैं, जीन एडिटिंग या जीनोम एडिटिंग, चाहे वो CRISPR-Cas से हो या जीन ड्राइव टेक्नोलॉजी से हो, तो वहां पे आपको इंस्टीट्यूशनल कमेटी से ही अप्रूवल लेना पड़ता है. दूसरी जितनी भी स्टेट लेवल से डिस्ट्रिक्ट लेवल से लेकर सेंट्रल लेवल की जो कमेटी है वहां अप्रूवल आपको नहीं लेनी पड़ती. While in the case of GM crops you have to take this type of different biosafety trial and approval. In the time, one of the most important parameter, जीनोम एडिटिंग के लिए टाइम रिक्वायर है काफी लेस है, बिकॉज वहां पे अप्रूवल से लेके जो ट्रायल है वो काफी लिमिटेड कंडीशन में आपको करना होता है. वहीं पे अगर आप GM क्रॉप्स की अगर बात करते हैं तो इट्स टेक टाइम, बिकॉज अप्रूवल जो मेजर थिंग है वो है अप्रूवल, एंड सेकंड थिंग इज इथिकल इशू. वहां पे दिस इज मेजर कंसर्न. सो हियर यू कैन सी द एग्जांपल दैट इफ GM क्रॉप की अगर बात करें तो बीटी कॉटन है, और अगर जीनोम एडिटिंग की बात करते हैं तो GM सांबा मैसूरी राइस. सो अगर हम जीनोम एडिटिंग CRISPR-Cas की बात करते हैं या जीनोम एडिटिंग जो ICAR ने इनिशिएट किया है, ICAR बेसिकली जो ये प्रोग्राम इनिशिएट किया है उसमें CRISPR-Cas टेक्नोलॉजी को स्टार्टिंग में इंट्रोड्यूस किया था, और उस CRISPR-Cas को बेसिकली जो सिकल सेल एनीमिया है उस पर ट्रायल करके उस टेक्निक को बाद में इंट्रोड्यूस किया. बट द मेजर थिंग इज CRISPR-Cas टेक्नोलॉजी वो पेटेंटेड है, तो अगेन इट टेक फाइनेंशियल बर्डन. तो इंडियन साइंटिस्ट लाइक CRI and this ICR Central Rice Institute, along with the different institute, they have used this intrinsic transposable mechanism that we call as TNP based genome editing tool. तो उसकी वजह से क्या होगा, वो इंडिपेंडेंट या हम बोल सकते हैं होममेड टेक्निक है, जिसकी वजह से आपको CRISPR-Cas के जो पेटेंटेड मटेरियल है वो बाहर से मंगाने नहीं पड़ेंगे. सो बिकॉज ऑफ दैट इट इज मोर इजी एंड अफोर्डेबल टू गो फॉर द मास लेवल ऑफ जीनोम एडिटिंग ऑफ ऑल द लिस्टेड, आई थिंक सो 17 क्रॉप्स वर लिस्टेड. So if we see the conclusion of this seminar, whatever the data we are generating using this RNAi technology and CRISPR-Cas technology, उस डेटा को कहीं ना कहीं आप एक रेफरेंस डेटा के तौर में यूज करके आपके जो AI प्रोग्राम है उसके अंदर यूज कर सकते हो. अब AI प्रोग्राम के अंदर बेसिकली अगर आप देखें आज के टाइम में तो दो मेजर इनिशिएटिव गवर्नमेंट और वेरियस इंस्टीट्यूशन के द्वारा लिए जाते हैं. फर्स्ट वन इज टू डेवलप वेरियस AI बेस्ड डिटेक्शन डिवाइस. वो बायोटिक एबायोटिक फैक्टर के जो भी पिक्चर है या जो इमेज है, चाहे वो जेल की इमेज है या फील्ड की इमेज है, उन सब डेटा को लेके एक रेफरेंस डेटा बनाया जाता है. उस रेफरेंस डेटा को AI बेस्ड जो टूल है वो फील्ड बेस्ड डेटा को ट्रैक करके आपके जो रेफरेंस डेटा है जो आपने रिसर्च पेपर में या लिटरेचर में जो पब्लिश किए हुए उस डेटा को रेफरेंस लेके वो फील्ड में आपको हेल्प कर सकता है फॉर आइडेंटिफिकेशन वेदर द पर्टिकुलर color incident which is showing in any part of the crop, it is whether due to the biotic factor or abiotic factor. Second one is detection of the pathogen. जैसे मैंने कहा in starting of the slide that detection of pathogen, there are various pheromones are released by the plant, various volatile compound released by the pathogen or plant, or during the interaction of both this plant and pathogen, during the interaction various this VOC compound are released. So that can be also identified using this AI based tool, and this type of information can be used to develop various you can say tools technique to minimize the impact of biological or abiological factor on the crop, and it will help to like a farmer and scientific community to increase the yield of that particular crop. So what are the future thrust? The integration of the big data, artificial intelligence, machine learning language, enhance more efficient monitoring and predicting of the insect related issue, contributing more effectively management strategy. So यहाँ पे आप AI and machine language का यूज करके different mathematical model बना सकते हो, जहाँ पे आपके पास जो भी अभी तक का डेटा है, सपोज यू कैन टेक द एग्जांपल ऑफ XYZ इंसेक्ट, उस इंसेक्ट का रबी और खरीफ के अंदर किस सीजन में कौन से ह्यूमिडिटी, कौन से मेट्रोलॉजिकल जो भी पैरामीटर है उस टाइम पे पॉपुलेशन क्या रहता है, ब्रीडिंग कौन से टाइम में ज्यादा होती है, व्हाट आर द फेवरेबल कंडीशन, ये सब डेटा लेके आप एक मैथमेटिकल मॉडल बना सकते हो जो आने वाले टाइम पे आपको एक फ्यूचर पर्सपेक्टिव के लिए यूज हो सकता है कि इस टाइम पे ये सीजन है तो ये डिजीज आने के चांसेस इस क्रॉप में इस एरिया में ज्यादा है. तो दिस टाइप ऑफ मैथमेटिकल मॉडल हेल्प टू प्रिडिक्ट and whatever the prevention measure you have to take that can be mass level contribute to the farmer using the IT technology, चाहे वो SMS हो या whatever the different technology which are adopted by different department. So advanced like RNAi CRISPR approaches can be used to silence and edit the susceptible and negative regulated alleles of plant immunity gene for developing the insect resistance in plant. So various ongoing development in plant genetic and biotechnological provide existing possibility for the control of pest management population in the environment friendly manner. So the potential of gene drive to contribute the sustainable and effective insect pest control appearing most promises. मैं यहाँ पे ये भी आपको बताना चाहूंगा, ऐसा नहीं है बायोटेक्नोलॉजी इज द ओनली वे. अपार्ट फ्रॉम दैट बायोइन्फॉर्मेटिक्स की अगर बात करूं तो बायोइन्फॉर्मेटिक्स में भी आज के टाइम पे यू आर नोइंग दैट गवर्नमेंट इज मोर फोकसिंग ऑन द सस्टेनेबल एग्रीकल्चर. तो सस्टेनेबल एग्रीकल्चर में फॉर द मैनेजमेंट ऑफ द इंसेक्ट पेस्ट मैनेजमेंट आप क्या कर सकते हो, सो यू कैन आइडेंटिफाई वेरियस पोटेंशियल phytochemical compound, or you can say the secondary metabolites which are released by the microbes that can be used as an analog of pesticide. तो आपको यहाँ पे ये आइडेंटिफाई करना है कि ऐसे कौन से मेटाबोलाइट्स हैं, चाहे वो इंसेक्ट प्लांट में से हो या बैक्टीरिया में से हो, जो पेस्टिसाइड के एनालॉग हो, चाहे वो 10% हो, 20% हो या 30%. तो उसको आप ऐसा बायोपेस्टिसाइड यूज करके क्लिनिकल ट्रायल करके जहां बायोइन्फॉर्मेटिक्स की डिफरेंट एप्लीकेशन आती है जिसको हम बोलते हैं प्रोटीन डॉकिंग, तो ये सब अप्रोच यूज करके आप यू कैन आइडेंटिफाई द पोटेंशियल फाइटोकेमिकल कंपाउंड और फाइटो सेकेंडरी मेटाबोलाइट्स फ्रॉम द बैक्टीरिया that can be used to minimize the impact of your pesticide in the field and can be mass level, you can say, recommend to the farmer as a terms of biopesticide. So I think so I've given the basic information regarding this topic. So I will be more like happy if you make interaction with me, and if you have any doubt, you can ask regarding this topic. Hello, Neha madam. Hello. So people can also raise the question in chat box.
Yes, thank you, sir. Sir, yeah, I was in that process only. I'm just about to like enable the chat box, and all the participants like who are having the queries, they'll drop their questions in that, and then you can like answer accordingly. Just a minute, sir. I'm just enabling the chat box.
Okay.
Chat box is enabled, so participants can like drop their questions right there. I guess the questions have started arising.
UV light trap insect and pest suitability in agriculture system. See, UV light trap is no doubt, apart from the UV light trap, there is yellow sticky pipe. But the thing is, UV light infrastructure, whatever the lamp, or you can see the back end side of that particular UV light, जो भी आपका मटेरियल है, वो आज के टाइम में स्पेशली इफ यू सी लास्ट 2 to 3 month, जो भी ये एनर्जी क्राइसिस हुआ है, एनर्जी क्राइसिस में काफी हमारा इंपोर्ट एक्सपोर्ट डिस्टर्ब हो गया है। तो मेजरली जो भी यूवी लाइट्स के जो ट्रैप बनते हैं, वो हम बाहर कंपनियां जो है वो मेजरली बाहर से यूज करती है। एंड अगेन अगर आप देखो तो यूवी लाइट का जो भी एक टाइम ड्यूरेशन होता है, तो लैंप के बाद उसका जो वेस्ट है, वो वेस्ट मटेरियल को डिग्रेड करना इट इज टीडियस। So it is suggestible to the farmer to use the biological mechanism, चाहे वो इंसेक्ट ट्रैप के लिए येलो स्टिकी पाइप हो या फिर दूसरे आईपीएम मैनेजमेंट हो जो बायोलॉजिकल हो, वो ज्यादा इजी है। दूसरा आप इसमें ले
So one more.
ओके, सी एआई अगर हम देखें तो एआई के अंदर प्रोग्रामिंग का जो पार्ट है वो काफी बड़ा है। न्यूरल नेटवर्क्स है, फिर उसके बाद डिफरेंट एल्गोरिथम आते हैं। तो एआई का यूज आप इस तरीके से कर सकते हो कि नॉर्मली बायोलॉजिकल अगर हम कंसेप्ट की बात करें तो यूकैरियोट, प्रोकैरियोट, हर सिस्टम के अंदर डिफरेंट मैकेनिज्म होते हैं। उस मैकेनिज्म को यूज करके एसएनपी क्या है, एसएनपी को फाइंड आउट करना है, फिर उसके बाद ट्रांसवर्जन, इस तरह के जो भी बेसिक फिनोमिना, बायोलॉजिकल के फिनोमिना है, वो आप एक बार एआई को डेटा से ट्रेन कर दो, तो वो आपके जब रो डेटा दोगे तो उसमें से डेटा माइनिंग करने के लिए एआई काफी इजी हेल्प करेगा। नॉर्मली आज के टाइम में जितने भी डेटा असेंबली होती है आफ्टर सीक्वेंसिंग, वहां पे हम एआई का यूज इतना नहीं करते, एक लिमिटेड प्रोग्राम का यूज करते हैं। लेकिन धीरे धीरे एआई को एज इंटीग्रेटेड फार्म प्रोग्राम में यूज किया जा रहा है, जिससे जो आपका जीनोम असेंबली अगर हो, चाहे वो ट्रांसक्रिप्टोमिक्स हो या प्रोटियोमिक्स लेवल पे हो, जो भी लेवल पे असेंबली हो, वो ज्यादा एक्यूरेट हो, और आपको जो बायोलॉजिकल न्यूक्लियोटाइड के जो वेरिएशन है या उसके जो इंटरप्रिटेशन है वो जेन्युइन मिले। सी अगर हम एआई का, जैसे द पर्सन इज आस्किंग एआई बेस्ड इंस्ट्रूमेंट टू आइडेंटिफाई एंड ट्रैक प्रिकॉशन विल हेल्पफुल विथ लोअर फार्म साइज पेस्ट मैनेजमेंट। सी आप इंस्ट्रूमेंट भी यूज कर सकते हो, एआई एप्लीकेशन भी यूज कर सकते हो। तो इंस्ट्रूमेंट की जैसे मैंने बात की कि फिरोमोन, तो आप ऐसा डिवाइस बना सकते हो, एआई बेस्ड डिवाइस, जहाँ पे वो फिरोमोन्स एक ऑर्गेनिक वोलेटाइल कंपाउंड है जो रिलीज किया जाता है बाय मेल फीमेल इंटरेक्शन। दूसरा, जब प्लांट स्ट्रेस रिलीज करता है बायोटिक फैक्टर का, एबायोटिक फैक्टर का, तो वो भी वोलेटाइल कंपाउंड रिलीज करता है। जब प्लांट पे कोई इंसेक्ट का इंसिडेंस होता है, तब भी वोलेटाइल कंपाउंड यूज किया जाए। तो आप किसी एक क्राइटेरिया को लेके, तो यहाँ पे अगर हम इंसेक्ट पेस्ट मैनेजमेंट की बात करते हैं, तो वहां पे आपका जो वोलेटाइल कंपाउंड है दैट कैन बी कंसिडर एज एन पैरामीटर। तो उस पैरामीटर को जो सेंसर है वो सेंस करेगा, और सेंसर इंटरप्रिटेशन करके जो नियर बाई जो एप्लीकेशन है उसको इन्फॉर्मेशन भेजेगा कि दिस टाइप ऑफ फिनोमोन कंपाउंड आर रिलीज। So this pheromone compound are very specific to the different types of insect. So based on the type of the volatile compound combination, you can predict and have a basic idea कि इस फार्म पे ये इंसेक्ट का पॉपुलेशन आने वाला है। सेकेंड थिंग इज, मैंने कहा कि एआई बेस्ड पिक्चर। अब नॉर्मली यू आर नोइंग कि किसी भी पैथोजन का इंटरेक्शन, चाहे अगर आप स्पेसिफिक एक पैथोजन की बात करो, वायरस, तो वायरस का अगर इंटरेक्शन प्लांट में अगर होता है, तो देयर आर डिफरेंट कैटेगरीज ऑफ वायरस, और उनका खुद का एक फिनोमिना होता है, जैसे हम बोलते हैं मुगबिन येलो मोज़ेक वायरस, या फिर उसके बाद लीफ कर्ल वायरस आ गया। तो इस तरीके से डिफरेंट टाइप ऑफ वायरसेस आते हैं। तो जो फिनोटाइपिक पैटर्न देखने को मिलता है प्लांट में, उस डेटा को जो लिटरेचर में ऑलरेडी अवेलेबल है, उस डेटा को रेफरेंस करके एआई स्क्रीन करके आपको बता सकता है कि ये इमेज इससे मैच हो रही है, तो इस टाइप का इन्फेक्शन हो सकता है। तो प्राइमरी इंफॉर्मेशन जो एक रिमोट एरिया में पर्सन बैठा हो या ग्रुप ऑफ कम्युनिटी पे बैठा है उनको दे सकता है, जिससे उनको फार्मर को अगर इंफॉर्मेशन देनी है तो इजीली हो सकता है। ओके, नैनो पार्टिकल कैन ऑल्सो बी यूज एज एन नैनो पेस्टिसाइड। तो जहां पे आप नैनो पार्टिकल को रिस्पेक्टिव जो डिफरेंट नैनो पार्टिकल है उन नैनो पार्टिकल को जो रेफरेंस आपके पेस्टिसाइड उसको कोट कर सकते हो, जिससे धीरे धीरे जो पेस्टिसाइड है वो सॉइल में रिलीज होंगे और मिनिमम यूज होगा पेस्टिसाइड का। सी, अगर हम जीन स्टैकिंग की बात करते हैं तो जीन स्टैकिंग के लिए फर्स्ट यू शुड बी नोइंग दैट व्हाट आर द डिफरेंट जीन दैट आर रिस्पॉन्सिबल फॉर डिफरेंट ट्रेट, चाहे वो सेक्स के लिए हो या फिर कोई पर्टिकुलर फिनोटाइपिक कैरेक्टर के लिए हो, या फिर जितने भी फिनोटाइपिक कैरेक्टर हमने जो आगे आगे एक मैंने स्लाइड में डिफरेंट पैरामीटर बताए थे, तो उन सब पैरामीटर के लिए आपको पता होना चाहिए कि कौन से जीन किस ट्रेट के लिए रिस्पॉन्सिबल। अगर वो आपको पता है तो आप जीन स्टैकिंग अप्रोच या जीन ड्राइव टेक्नोलॉजी है वो इंसेक्ट में अप्लाई कर सकते हैं। अगर मैं इसका क्लासिकल एग्जांपल दूं तो आई वांट टू जस्ट गिव यू एन एग्जांपल, लेकिन एक साउथ की भी आई थी जहां पे ग्राफर बताया था, वहां पे उस पिक्चर में कहीं ना कहीं जिस जीन ड्राइव टेक्नोलॉजी के बारे में बताया गया, जहां पे जो ग्रासहोपर है उसके अंदर वो जीन को मॉडिफाई किया गया, जिसकी वजह से उनकी जो खाने की कैपेसिटी है वो काफी बढ़ गई, एंड बिकॉज ऑफ दैट मास में वो ब्रीडिंग करते हैं और मास में पूरा फार्म को विद इन शॉर्ट ड्यूरेशन वो फार्म को फिनिश कर देते हैं। सो देर आर नेगेटिव इम्पैक्ट ऑल्सो, बट यू हैव टू कीप इन माइंड कि आपको कौन से जीन को या कौन से ट्रेट को टारगेट करना है। Okay, so second question is, can AI predict the resistance background in insect or pesticide? See, AI रेजिस्टेंस बैकग्राउंड को प्रिडिक्ट करने के लिए आपको मैथमेटिकल मॉडल बना सकता है, लेकिन उसके लिए आपको डिटेल मैकेनिज्म पता होना चाहिए। वो पेस्टिसाइड कैसे वर्क करता है, दूसरा मेटाबॉलिक पाथवे जो इंसेक्ट के अंदर होती है वो कैसे वर्क करती है या उसको कैसे ओवरकम करती है, इस तरीके का बेसिक मेटाबॉलिक इंफॉर्मेशन अगर आपके पास होगा तो आप मैथमेटिकल मॉडल बना सकते हो और उससे प्रिडिक्ट कर सकते हो कि ये पेस्टिसाइड इन फ्यूचर रेजिस्टेंस शो करेगा कि नहीं। Is gene knocking feasible for several future generation? So you are asking in which context? Can you like elaborate this question? यस, अगेन जैसे आपने फ्रूट फ्लाई में कहा, नॉर्मली अगर आप फ्रूट फ्लाई की बात करें, हमारे गुजरात में स्पेशली फ्रॉम द नवसारी एग्रीकल्चर यूनिवर्सिटी वी हैव अ पेटेंट फॉर द फ्रूट फ्लाई ट्रैप। सो नॉर्मली उस फ्रूट फ्लाई के अंदर हम जो फिरोमोन्स है वो यूज करते हैं और वो फिरोमोन्स जो इंसेक्ट है उसको ट्रैप कर लेते हैं एंड इट मिनिमाइज द पॉपुलेशन ऑफ दैट पर्टिकुलर फ्रूट फ्लाई। तो यहाँ पे आप ये कर सकते हो, जो मैंने कहा कि फ्रूट जो फिरोमोन्स है, फिरोमोन के अंदर काफी वोलेटाइल कंपाउंड की कॉम्बिनेशन रहता है। तो उस वोलेटाइल कंपाउंड को अगर आप एआई बेस्ड टूल, अगर आपका वहां पे सेंसर बेस्ड टूल, आपने जिस तरीके से फ्रूट फ्लाई टेप लगाते हो उस तरीके से आप एआई बेस्ड सेंसर हर एक फार्म के एक पर्टिकुलर लिमिटेशन एरिया, क्योंकि वो डिपेंड करेगा एआई का जो सेंसर है वो उसकी कैपेसिटी क्या है। तो कैलकुलेशन के हिसाब से अगर आप एआई सेंसर को वहां लगा देते हो तो वो एआई सेंसर है वो इन्फॉर्मेशन को डिटेक्ट करेगा कि कौन से वोलेटाइल कंपाउंड रिलीज हो रहे हैं, कितने रिलीज हो रहे हैं। दैट टाइप ऑफ डेटा कैन बी fetched by that sensor and it will be given to the machine and it will interpret and it give you an information के pheromones का जो वोलेटाइल कंपाउंड है वो सेंस होना चालू हो गया, तो इसको आप इससे आपको बेसिक आइडिया मिलेगा कि फ्रूट फ्लाई का इंसिडेंस चालू हो गया है। See, for the pest resistance for several generation is knockdown is a feasible method. See, the best example is बीटी कॉटन। आप बीटी कॉटन में देख सकते हो बोलगार्ड 1 बनाया, बोलगार्ड 2 बनाया, बोलगार्ड, जितने भी बोलगार्ड बनाते हो तो सामने इंसेक्ट भी एक नेचुरल फिनोमिना है। वो भी अपना जो डार्विन्स की नेचुरल थ्योरी है उसको फॉलो करके अपने आप को सर्वाइवल के लिए बेस्ट बिहेव करता है। तो इट इज नॉट फिजिकली पॉसिबल, बट दूसरा के जीन नॉकडाउन के लिए अगर आपको डिफरेंट ट्रायल्स लेने पड़ेंगे, जेनेटिक मॉडिफिकेशन अगर आप करते हो तो यू हैव टू गो अगेन लॉन्ग टर्म अप्रूवल मेथड, लॉन्ग टर्म ट्रायल मेथड, और जो वो पीरियड है आज के टाइम में ड्यू टू द क्लाइमेटिक कंडीशन, अगर आप देखें लास्ट 2 से 3 साल की अगर बायोटिक एबायोटिक फिनोमिना अगर आप देखते हैं किसी क्रॉप की तो ड्रास्टिकली चेंज हो रही है, तो वहां पे ये प्रोसेस काफी अनस्टेबल रहेगा। सी, मेजर चैलेंजेस की अगर बात करें, इम्प्लीमेंटेशन ऑफ दिस जेनेटिक पेस्ट मैनेजमेंट स्ट्रेटेजी इन स्पेशली डेवलपिंग कंट्री, अगर हम इंडिया की बात करें तो यहाँ पे देखा जाता है फिजिबिलिटी, क्योंकि यहाँ पे मेजर जो इशू आता है वो है किसी भी क्रॉप का अगर आप सोइंग पैटर्न देखो तो वो बहुत लिमिटेड होता है, तो उस लिमिटेड एरिया के अंदर वो फार्म एज अ फार्मर इट इज नॉट फिजिकली पॉसिबल टू गो फॉर द मॉडिफाइड क्रॉप्स या मॉडिफाइड टेक्नोलॉजी, क्योंकि यहाँ पे हमारे जो फार्म है वो काफी छोटे हैं। इंडिया की अगर हम बात करें तो मोर देन 90% जो फार्म है वो आपके काफी छोटे हैं, मतलब 1 बीघा 2 बीघा 3 बीघा के कैपेसिटी में, तो वहां पे टेक्नोलॉजी बेस करना काफी चैलेंजेस है। तो वहां पे आप जो हम बोल सकते हैं एक फिजिबल मेथड है आईपीए मैनेजमेंट की, जैसे कि फिरोमोन ट्रैप्स है, फिर उसके येलो स्टिकी पाइप है, तो इस तरीके से ट्रैप को यूज करके आप आपके एक so you answer which technique like yellow sticky pipe or pheromone based trap. Your question is, can the technique be used for household pests, especially mosquito, to avoid dengue and dangerous disease? So you are asking about pheromone trap. Please answer. So if your question is related to pheromone trap, so there is no like detect communicating during the male female. So is there any question from the audience? See, this is not the platform to discuss about the policy maker. मार्केट में काफी चीजें होती है, बट देर आर इंडस्ट्री, देर आर सेक्टर रनिंग दिस यू कैन से पॉलिसी, सो पॉलिसी मैटर को यहाँ डिस्कस ना करे तो काफी अच्छा है। But as a government, I can say that government is running nowadays. If you see, काफी डिफरेंट प्रोग्राम गवर्नमेंट के द्वारा चलाए जा रहे हैं, जहाँ पे उनको बताया जा रहा है कि कौन से पेस्टिसाइड यूज करना है, मिनिमम यूज करना है। दूसरा, पेस्टिसाइड की जगह बायो पेस्टिसाइड काफी इंसेक्ट में आ गए, तो वो आप यूज करिए। इवन जो स्मॉल स्केल फार्मर है उनको ये कहा जा रहा है कि आप गवर्नमेंट के थ्रू, चाहे वो केवीके हो या यूनिवर्सिटी, डिफरेंट प्लेटफॉर्म के थ्रू ये बताया जा रहा है कि आप इस तरीके से जो आईपीएम मैनेजमेंट के प्रैक्टिसेस उसको यूज कर सकते हो, जैसे येलो स्टिकी पाइप है या फिरोमोन ट्रैप्स है, तो जिससे मिनिमम आपको पेस्टिसाइड का यूज कर पाए। वो डिपेंड फार्मर पे करता है कि उसको कौन चीजें अवेलेबल है या कौन सी जल्दी से मिल पा रही है, क्योंकि कभी कभी ऐसा होता है कि जो मैंने फ्रूट फ्लाई ट्रैप और इन सब की बात की, यूनिवर्सिटी लेवल पे तो दिक्कत नहीं आती है, लेकिन प्राइवेट कंपनियों या फिर दूसरी नियर बाई जो आपके रिटेलर स्टोर, वहां से मिनिमम आपको क्वांटिटी परचेस करनी होती है। ओके, पेस्ट कंट्रोलिज्म को अगर आपको एआई बेस्ड टेक्नोलॉजी से यूज करना है तो आप पेस्ट डिटेक्ट कर सकते हो। दूसरा, पेस्ट डिटेक्शन के बेस पे फार्मर को इस टूल के थ्रू इंफॉर्मेशन दे सकते हो कि if he or she has to go for like pesticide, so these are the pesticide. So दूसरा बायोपेस्टिसाइड अगर यूज है तो ये सारे पेस्टिसाइड है। तो फार्मर को जस्ट he or she has to scan the plant material and based on the trained data of that insect if it is available in the system, वो आपको बताया कि आप ये इंसेक्ट का पैटर्न दिख रहा है तो ये दो इंसेक्ट का पैटर्न दिख रहा है तो यू कैन यूज द कॉम्बिनेशन ऑफ टू पेस्टिसाइड एंड आपको वहां पे बेसिक फूड देनी होगी कि मेरा क्रॉप इतने स्टेज का है या इतने डेज हो गए हैं, तो बेस्ड ऑन दैट इंफॉर्मेशन वो आपको क्वेश्चन पूछने के बाद वो आपको बताएगा कि दिस मच डोज इज रिकमेंडेड एट दिस स्टेज, तो उससे पेस्टिसाइड का यूज मिनिमम कर सकते हैं।
Sir, I have also received some questions. If you would give me permission, I would ask you some. Sir, one question is, what role does genomics play in understanding insect behavior, adaptation, and resistance development?
ओके जैसे मैंने कहा कि इंडिया के अंदर अभी जो जीनोमिक्स के लिए मेजर गवर्नमेंट फोकस कर रही थी, इवन आईसीआर वो क्रॉप के कर रही थी, लेकिन इंसेक्ट के इसमें भी इसलिए देखा गया क्योंकि कभी कभी इंसेक्ट के अंदर रेजिस्टेंस मैकेनिज्म कैसे होता है, व्हाट आर द वाइटल जीन विच आर कॉमन इन डिफरेंट ग्रुप्स ऑफ इंसेक्ट, चाहे वो लेप्टेरा हो स्पोडोप्टेरा हो, तो इनका कौन से कॉमन जीन है, कौन से यूनिक जीन है जिसकी वजह से उस इंसेक्ट को वो यूनिक बनाता है। तो इसकी वजह से जीनोम सीक्वेंसिंग करना जरूरी पड़ता है। जीनोम सीक्वेंसिंग करने के बाद आपको पता चलता है कि इफ यू कंपेयर योर रेफरेंस, सपोज रेफरेंस के अगर हम इंसेक्ट की बात करें तो वन ऑफ द मेजर रेफरेंस इंसेक्ट की बात वो है आपका ट्रोपिला मेलानोगास्टर, ठीक है। तो उससे आपके मैंने अभी सपोज कोई स्पोडोप्टेरा जैसे मैंने फॉल आर्मीवॉर्म की बात की, अगर मैं उसके सीक्वेंस करता हूँ तो जो मेलानोगास्टर है उसका 100% जीनोम क्या बोल सकते हैं डिफाइन हो गया है, कौन सा जीन किसके लिए रिस्पॉन्सिबल है। तो अगर मैं मेलेनोकेस को मेरे इंसेक्ट के साथ टू 90% इंफॉर्मेशन मिल जाएगी क्योंकि वो दोनों इंसेक्ट कैटेगरी में आते हैं, तो मुझे खाली 20% 10% कितना वो मेरा ऑर्गेनिज्म उस मेलेनोकेस्टर से डिफरेंट है उसके बेस्ड इंफॉर्मेशन को मतलब उतनी उतनी इंफॉर्मेशन कम मिलेगी और इस इंफॉर्मेशन की वजह से मुझे पता चलेगा कि जीनोम के अंदर कितने कोडिंग पार्ट है विच आर द वाइटल जीन विच मेक्स वन इंसेक्ट डिफर फ्रॉम अदर, और उसको अगर मैं उस जीनोम को एक आगे लेके जाता हूँ लेवल पे या ट्रांसक्रिप्शन लेवल पे, तो मुझे पता चलेगा कौन सी किस कंडीशन में क्या बोलते हैं एक्सप्रेस हो रही है। नॉर्मली अगर हम इंसेक्ट की बात करें तो इंसेक्ट के अंदर एग आया, एग के बाद लार्वा आया, प्यूपा आया, एडल्ट आया, तो जो मेटामॉर्फोसिस हो रहा है मेटामॉर्फोसिस में कौन से जीन ऑन है कौन से ऑफ है कौन से ऑन है, तो इस तरीके से आपको डिफरेंट कॉम्बिनेशन ऑफ जीन की पैटर्न पता चलती है।
Okay, sir. So one more question, that how are next generation sequencing technologies contributing to insect pest research and management?
आज टाइम में जितने भी नेक्स्ट जनरेशन टेक्नोलॉजी यूज की जा रही है उसका मेन जो मोटो है वो है जितनी भी स्ट्रेन, जैसे आप प्लांट में देखो प्लांट के अंदर डिफरेंट जीनोटाइप्स होते हैं, तो इस तरीके से इंसेक्ट में भी हम हैप्लोटाइप्स बोलते हैं। तो वो हैप्लोटाइप सपोज करो फॉल आर्मीवॉर्म है, तो फॉल आर्मीवॉर्म सपोज मेज का मुझे यहाँ नॉर्मली अगर फॉल आर्मीवॉर्म की बात करें तो उसके अंदर दो स्ट्रेन आती है सी एंड आर। तो गुजरात के अंदर मेज के अंदर सपोज वो आर स्ट्रेन को बिलोंग करता है, यूपी के अंदर वो सी स्ट्रेन को बिलोंग करेगा। तो इस तरीके से इंसेक्ट के अंदर जो हैप्लोटाइप्स है या जो वेरिएंट है वो आपको पता चलेंगे, उसके बेस पे आप उसके फिनोटाइपिक कैरेक्टर को कोरिलेट करके बता सकते हो कौन सा ज्यादा एग्रेसिव है, वो एग्रेसिवनेस उसके जीनोटाइप जेनेटिक मटेरियल से कोरिलेट करके इंफॉर्मेशन को डिटेल वो कर सकते हो आप, और ये कहीं ना कहीं आईपीएम मैनेजमेंट के लिए यूज हो सकती है।
Okay. So one more, that how can molecular approaches help in conserving beneficial insects while targeting the harmful pest species?
उसके लिए आपको जो बेनिफिशियल इंसेक्ट है, इसलिए मैंने कहा जीनोम सीक्वेंसिंग किया जाता है क्योंकि जीनोम सीक्वेंसिंग में ये देखा जाता है कि जो बेनिफिशियल और जो पैथोजेनिक इंसेक्ट है उन दोनों के अंदर किसी मेटाबॉलिक पाथवे की अगर हम बात करते हैं, मेटाबॉलिक पाथवे में कौन से मेटाबोलाइट्स दोनों में कॉमन है, कौन पैथोजेनिक वाले में कौन से यूनिक है, जिससे आप स्पेसिफिक उस मेटाबोलाइट को ही टारगेट करो जो पैथोजेनिक इंसेक्ट है उसके अंदर देखने को मिलता है और नॉर्मल अंदर नहीं है। तो उसके लिए जरूरी है कि आपको हर एक लेवल पे, जीनोमिक लेवल पे, ट्रांसक्रिप्टोमिक्स लेवल पे, प्रोटियोमिक्स लेवल पे सारे पाथवे को कंबाइन करना पड़ता है, जिससे आपको पता चले कि बेनिफिशियल इंसेक्ट के अंदर इतने मेटाबॉलिक पाथवे हैं और उस मेटाबॉलिक पाथवे में इतने मेटाबोलाइट्स कॉमन है। वाइल इन द केस ऑफ पैथोजन ये XYZ मेटाबोलाइट से जो पाथवे है वो डाइवर्ट हो रहा है, जिससे आप स्पेसिफिक उस मेटाबोलाइट को ही टारगेट करो एंड द टारगेट विल बी वेरी स्पेसिफिक। और सीक्वेंसिंग टेक्नोलॉजी या सीक्वेंसिंग जो अप्रोच है उसका मेन टारगेट ही यही है कि टारगेट बेस्ड प्रोडक्ट मार्केट में लाया जाए।
सर वन मोर क्वेश्चन कि लिमिटेशंस क्या है मॉलिक्यूलर और जेनेटिक अप्रोचेस की जब हम उसका फील्ड लेवल पे इम्प्लीमेंटेशन करते हैं, स्पेशली जो डेवलपिंग कंट्रीज हैं लाइक इंडिया उसमें?
जी, जैसे मैंने कहा कि डेवलपिंग कंट्री में मेजर जो इशू आता है, फर्स्ट वन इज अप्रूवल, या दूसरा भी अगर हम देखें तो कोई भी अगर आपको ट्रांसजेनिक अप्रोच यूज करना है, जीनोम एडिटिंग यूज करना है, तो जैसे मैंने कहा क्रिस्पस टेक्नोलॉजी है, तो क्रिस्पस टेक्नोलॉजी हो टू टेक फ्रॉम द अदर कंट्री और अदर डेवलपिंग इंस्टीट्यूट, तो वहां से आपको वो क्रिस्पस का पेटेंट रहेगा और पेटेंट लेने के बाद देर आर लिमिटेशन, वो आधी चीज देगा आधी चीज नहीं देगा। कभी कभी ये होता है कि ओके यू गेट द मटेरियल, पेटेंटेड प्रोडक्ट मिल गया, लेकिन उसको आपके अप्लाई करना है, यू रिक्वायर फाइनेंशियल सपोर्ट, यू रिक्वायर गवर्नमेंट सपोर्ट। दूसरा ये सब होने के बावजूद भी यू रिक्वायर अ प्रॉपर एरिया फॉर द क्वारंटाइन जहाँ पे आप ये ट्रायल कर पाओ। और दूसरा जो मेजर थिंग आती है वो क्लाइमेटिक कंडीशन, आप जो करना चाहते हो वो क्लाइमेटिक कंडीशन अगर फेवर नहीं करेगी या एबनॉर्मल कंडीशन रहेगी तो आप स्क्रीन नहीं कर पाओगे कि ये जो एबनॉर्मल रिजल्ट आ रहा है वो मेरे वर्क की वजह से आ रहा है या क्लाइमेटिक कंडीशन की वजह से आ रहा है। तो दिस आर द मेजर चैलेंजेस इन मॉलिक्यूलर टेक्निक्स।
Okay, sir. One more thing, that how are like what role does genomics play in understanding the insect behavior, adaptation, and resistance development?
सी जैसे मैंने कहा जीनोमिक्स अगर किसी भी इंसेक्ट का किया जाता है तो उसमें मेजर चीजें ये पता चलती है। जैसे मैं एक क्लासिकल एग्जांपल रहूंगा, रिसेंटली माय स्टूडेंट हैज वर्क ऑन स्टिंगलेस बी। अगर हम स्टिंगलेस बी की बात करें तो जेनेटिक मटेरियल आप वर्कर का कंपेयर कर सकते हो मेल के साथ और उसके साथ फीमेल का भी कंपेयर करोगे तो पॉइंट जो 1% वेरिएशन आता है जिसकी वजह से मेल या जिसको हम बोलते हैं ड्रोन, वर्कर और क्वीन एक दूसरे को अलग बनाता है। तो कौन से ऐसे ट्रेड है जिसकी वजह से वो ड्यूरिंग दिस, क्योंकि जब एक बनता है तो ऐसा तो नहीं है कि फीमेल का एक अलग आता है या फिर ड्रोन का एक अलग आता है या वर्कर का एक अलग आता है। सो फ्रॉम द egg there are various biochemical process which are giving responsible to make this diversion, और वो कहीं ना कहीं that biochemical changes जो metamorphosis हो रहे हैं वो हम identify करते हैं and if you are knowing this thing you can change the process। क्योंकि कभी कभी ये होती है कि जैसे मैंने कहा व्हाइट फ्लाई, तो व्हाइट फ्लाई के अंदर व्हाइट फ्लाई सॉरी दिस स्टिंगलेस बी, तो स्टिंगलेस बी के अंदर कभी कभी ये होता है बिकॉज ऑफ द क्लाइमेटिक कंडीशन या पेस्टिसाइड फीमेल डिस्टर्ब हो जाती है। तो इफ यू आर नोइंग दिस टेक्नोलॉजी यू कैन डेवलप न्यू क्वीन इन योर अपकमिंग पॉपुलेशन। सी अगर आपको ट्रेनिंग प्रोग्राम के लिए जाना है तो यू कैन गो फॉर द वेबसाइट ऑफ NBPGR, नेशनल ब्यूरो ऑफ इंसेक्ट पेस्ट मैनेजमेंट। वहां पे वो अलग अलग मॉलिक्यूलर टेक्निक करवाते हैं जहाँ पे फील्ड ट्रायल और लैब ट्रायल दोनों के बारे में इंफॉर्मेशन देते हैं।
सर एक क्वेश्चन है कि हाउ इफेक्टिव आर जेनेटिकली मॉडिफाइड क्रॉप्स इन मैनेजिंग इंसेक्ट पेस्ट कंपेयर टू कन्वेंशनल पेस्ट कंट्रोल मेथड्स?
सी कन्वेंशनल में जो इशू आता है वो ये आता है कि मल्टीपल पेस्ट एक ही क्रॉप में आती है। वहीं अगर हम GM क्रॉप की बात करें, जैसे GM BT कॉटन की बात करते हैं, बोलगार्ड 1 बोलगार्ड 2, तो वो बोलगार्ड 1 2 क्या है? बोलगार्ड 1 इंडिकेट रेजिस्टेंस टू वन स्पेसिफिक इंसेक्ट, बोलगार्ड 2 इंडिकेट रेजिस्टेंस विथ टू दैट पर्टिकुलर क्रॉप विथ अनदर इंसेक्ट। तो जिस तरीके से बोलगार्ड 1 2 3 है, वहां पे हम जीन पिरामिडिंग कर रहे हैं, वहां पे हम अलग अलग इंसेक्ट की जो फीड हो रहे हैं उस क्रॉप के ऊपर, उसको रेजिस्टेंस शो कर रहे हैं। तो आपका जो जीएम क्रॉप है, वो जीएम क्रॉप कहीं ना कहीं मल्टीपल रेजिस्टेंस एक ही क्रॉप के अंदर देता है, बट नेचर हैज आल्सो लाइक मूविंग वन स्टेप फॉरवर्ड टू अस। इसलिए आप देख सकते हो कि कॉटन में अगर हम देखें तो पास्ट ईयर में काफी हमने बोल गार्ड बनाया है, लेकिन उस बोल गार्ड के सामने हर एक टाइम पे न्यू इंसेक्ट का बोल सकते हैं आप इमरजेंस देखने को मिलता है। जैसे कॉटन में अगर हम रिसेंटली बात की जाए तो पिंक बोलवर्म का इशू काफी देखने को मिलता है। नो डाउट पिंक बोलवर्म के सामने अगेन वी हैव लाइक डेवलप बोलगार्ड 5 विच इज अंडर ट्रायल, लेकिन कहीं ना कहीं हम जिस हिसाब से एक स्टेप आगे बढ़ रहे हैं, नेचर भी एक स्टेप आगे बढ़ रहा है, इसलिए न्यू इंसेक्ट अपने आप को मैनेज करके उस क्रॉप या उस होस्ट को एज अ फीड पॉइंट ऑफ व्यू यूज करता है।
Okay. So one more thing, that could genetic pest management eventually replace the chemical pesticides on a large scale? सर आपको मतलब क्या लगता है कि ये जो जेनेटिक पेस्ट मैनेजमेंट हम कर रहे हैं,
तो
इससे जो हम केमिकल पेस्टिसाइड्स यूज करते हैं वो एक लार्ज स्केल पे रुक सकता है या नहीं, और अगर रुक सकता है तो
जैसे
इसके मतलब क्या रीजन रहेगा?
देखिए, मैंने एक काफी छोटा एक एग्जांपल दिया। जैसे इंडिया के अंदर मेजरली अगर आप फार्मर की बात करें तो लैंड रिक्वायरमेंट ईच फार्मर काफी छोटा है। वहीं पे अगर आप जेनेटिक मॉडिफाई जो भी मटेरियल है मॉलिक्यूलर बेस्ड टेक्नोलॉजी से जो आते हैं, जैसे मैं अगर बात करूं बीटी कॉटन, तो बीटी कॉटन का अगर आप मार्केट में लेने जाते हैं सीड मटेरियल, तो एक तो काफी कॉस्टली मिलता है, दूसरा पैकेट काफी छोटा मिलता है। तो एक छोटे फार्मर के लिए उस पैकेट को लेना, उसके बाद दूसरी प्रिकॉशन मेजर करना काफी टीडियस होता है, क्योंकि आपने नो डाउट जीएम क्रॉप्स ले लिए लेकिन बारिश नहीं हुई तो सो इट इज वेरी टीडियस। और सेकेंड, इसलिए पेस्टिसाइड का यूज कहीं ना कहीं ज्यादा रहेगा। क्यों? क्योंकि पेस्टिसाइड मार्केट में जैसे मैंने कहा डे बाय डे आजकल जो मार्केट में पेस्टिसाइड आते हैं वह काफी सिलेक्टिव पेस्टिसाइड आते हैं, जिसका मोड ऑफ एक्शन काफी एक्यूरेट रहता है। दूसरा, मार्केट में जो पेस्टिसाइड मिलते हैं वो काफी स्मॉल पैकेट्स में मिलते हैं, जिसको हम बोलते हैं पाउच या स्मॉल 50 ml 100 ml के उसमें। तो वो फार्मर के लिए इजी होता है टू सस्टेन, बिकॉज हम यहाँ जो बात करते हैं वो टेक्नोलॉजी की बात कर रहे हैं, लेकिन आप ग्राउंड लेवल पे देखोगे तो ग्राउंड लेवल पे जो मेजर इशू आता है वो लेबर का इशू आता है। तो लेबर और इन सब का अगर आप इनपुट कॉस्ट देखें तो फार्मर के लिए काफी टीडियस है टू यूज दिस टेक्नोलॉजी बेस्ड अप्रोच रेदर देन टू स्टॉप दिस पेस्टिसाइड अप्रोच।
ओके सर, हम ऐसी क्या मतलब पब्लिक अवेयरनेस और एक्सेप्टेंस ला सकते हैं जेनेटिकली बेस्ड पेस्ट मैनेजमेंट टेक्नोलॉजीज इंप्रूव करने के लिए?
जीएम क्रॉप की अगर हम बात करें तो वहां पे मेजर लिमिटेशन चाहे वो क्रॉप हो या इंसेक्ट दोनों में है। इसलिए यू आर सीइंग के जीएम क्रॉप का जो काम है वो कॉटन के अलावा काफी रेयर दूसरे क्रॉप में आगे बढ़ रहा था। इसलिए गवर्नमेंट ने, जैसे मैंने एक स्लाइड में बताया था, कि इनिशिएटिव लिया है और जीनोम एडिटिंग को मास लेवल पे प्रमोट किया है। वहां पे मैंने 17 आईसीआर क्रॉप्स के बारे में बताया था, जहां पे उसने हॉर्टिकल्चर क्रॉप, सीरियल क्रॉप, अलग अलग क्रॉप को मास लेवल पे सीक्वेंसिंग करने के बाद जीनोम एडिटिंग के लिए अप्रोच किया, क्योंकि जीनोम एडिटिंग के लिए आपको अप्रूवल इतना प्रोसीजर टीडीएस नहीं है। एंड दूसरी जो टेक्नोलॉजी है, क्रिस्पर टेक्नोलॉजी है या जीन ड्राइव टेक्नोलॉजी है, ये सब इजीली आप अप्लाई कर सकते हो कंपेयर टू दिस ट्रांसजेनिक अप्रोच।
ओके सर, हम फार्मर्स को कैसे लाइक अवेयरनेस क्रिएट कर सकते हैं या उनको कैसे एक्सेप्टेंस ला सकते हैं कि वो जेनेटिकली मॉडिफाइड क्रॉप्स यूज करें?
जैसे मैंने कहा कि पहले सीनेरियो ऐसा था कि हम फार्मर को अवेयरनेस कर सकते हैं। आज के टाइम में फार्मर इन फ्यूचर हम विदिन प्रमोट करके जीनोम एडिटिंग क्रॉप्स के कोई साइड इफेक्ट नहीं है कंपेयर टू जीएम क्रॉप्स। So one question
ओके
is that
सर,
GM crop are not organic and natural farming. So then how this crop can be sustained or replaced? See, GM crop का जो मेन काम है वो है टारगेट बेस्ड प्रोडक्ट को मास लेवल पे एक्सप्रेस करना उस क्रॉप में, चाहे वो एबायोटिक या बायोटिक फैक्टर को मिनिमाइज करना हो या न्यूट्रिशन पॉइंट ऑफ व्यू किसी क्रॉप में हाई लेवल पे एक्सप्रेस करना हो। तो उसकी वजह से वहाँ पे इथिकल इश्यू आते हैं, एलर्जिक इश्यू आते हैं, काफ़ी एक चैनल होती है या एक बोल सकते हैं एक कैस्केड ऑफ वर्क है जिसको आपको ओके करके ही मार्केट में लाना होता है। वहीं पे अगर आप नेचुरल फार्मिंग और ऑर्गेनिक की बात करते हो तो वहाँ पे आप मिनिमम एग्रीकल्चर इनपुट्स पे या मिनिमम बोल सकते हैं लेबर और इन सब का यूज़ करके आप नेचुरल फार्मिंग के थ्रू प्रोडक्ट को यूज़ कर सकते हो। लेकिन वहाँ पे अगेन एक मेजर जो इश्यू आएगा वो आएगा क्लाइमेटिक कंडीशन, क्योंकि क्लाइमेटिक कंडीशन दोनों में इक्वली इफेक्ट करता है।
Sir, I guess we are almost done with the questions.
Okay.
I guess most of them are answered, sir. I guess all are answered.
Okay.
Yeah. So, sir, like we'll be concluding this session. So,
Okay.
thank you, sir, for your enlightening and thought-provoking session. Your valuable insights into biotechnology, bioinformatics, then genomic sequencing, and emerging technologies in agriculture have greatly enriched our knowledge and inspired all the participants right here. So, on behalf of Just Agriculture Education Group, as well as the entire AgroVision 2.0 family, I sincerely thank you for sharing your expertise and spending your valuable time with us today. Thank you so much, sir.
Okay, thank you, ma'am.
Thank you, sir.
हमारे एक्चुअली मीटिंग हालती थी हाँ भाई वालता था छोकरा ने मैडू नाला होना मुकले जाए
Thank you all for your active participation and engagement. We will begin our next session shortly. Our esteemed guest speaker is expected to join us in 2 minutes. Meanwhile, we request everyone to stay connected and make the most of I guess our next guest has joined us. Ma'am, am I audible to you?
Yeah, hi. Hi, Neha. How are you?
I'm good, ma'am. How are you?
Yeah, I am good too. Thank you so much for waiting patiently.
Thank you so much, ma'am.
Yeah.
Ma'am, I'll be just starting with your introduction and then we can proceed with your session.
Okay, that would be great.
Okay. So, it is my great pleasure and privilege to introduce our distinguished keynote speaker for today's session, Dr. Samriti Mahajan. Dr. Samriti Mahajan is an associate professor, accomplished researcher, innovator, global speaker, and thought leader in the fields of management, sustainability, digital transformation, and emerging technologies. With over a decade of excellence in academia, she has made remarkable contributions to teaching, research, innovations, and leadership. She has an outstanding academic and research portfolio with more than 40 research publications, 46 patents across national and international jurisdictions, 7 books published by globally renowned publishers, and 19 book chapters. Her research expertise spans consumer behavior, green marketing, artificial intelligence, digital transformation, sustainability, and entrepreneurship. Dr. Mahajan has represented India on prestigious international platforms across more than 20 countries and is widely recognized for her contributions as a keynote speaker, session chair, mentor, and academic leader. Her excellence has been acknowledged through several prestigious honors, including recognition among the top 30 visionaries of India, the Nari Ratna Award, and the Chanakya Leadership Excellence Award. Beyond academics, she is deeply committed to leadership development, women empowerment, innovation, and creating sustainable impact through education and research. So, on behalf of Just Agriculture Education Group and the entire AgroVision 2.0 family, I extend a warm and heartfelt welcome to you, ma'am. Ladies and gentlemen, please join me in welcoming our esteemed keynote speaker, Dr. Samriti Mahajan. Thank you, ma'am, and over to you.
Thank you so much. Am I visible and audible both?
Yes, ma'am, you're visible and audible.
Yes, that's great. That's great. Let me just share my screen with you all.
Yes, ma'am.
Is it visible?
Yes, ma'am, it is visible.
And Neha, just let me know that if it is moving.
Ma'am, yes, you can just like start the slideshow. I'll let you
Yeah,
know.
I have started. So is it moving now?
No, ma'am, it is
No,
not
it's
moving.
still fine. I just need to change then it again. And how about now? Is it changing?
Yes, ma'am, now it's changing.
Okay, that's great. That's great. Okay, so let me just start. And thank you so much, everyone, for waiting patiently today. And good evening. I am Dr. Samriti Mahajan, and today we are going to talk about something that is both urgent and extraordinarily exciting. That is the future of feeding our planet, that how we are going to feed our planet. So the title says that 2050, but I want to be very clear with you all that this is not just a science fiction we should be talking about, but this is a strategic roadmap. The technologies on these slides are either already deployed at a scale or are in advanced pilot stages today. And when we are really discussing, that is a fundamental redesign of the global food system. So that we would be talking about. And when the question arises from each of you that we should be asking ourselves throughout the session that where does my role sit in that redesign? So that is the question we need to know. If we talk about the things, how we are going to aligning our position into the system. So we're talking with the first slide that yesterday's fiction that was in 1950s to 1960s era, and now we are going to ahead with the tomorrow's baseline. So let us start with the perspective. On the left, you can see the image that is from 1962 Chicago Turbine comic series, which is also called as the Colossal Crops, and what they imagined as outlandish futurism. the lab-grown hamburgers, food from 3D printers, drone-delivered produce, and on the right-hand side, what we can see, the future of tomorrow, which is
Ma'am,
the hello.
I'm sorry to interrupt, but the slides are not moving.
Slides are not moving.
Yes.
Wait. Are we on second slide now?
Yes, ma'am, I can see the second
And
one.
now this is the third
This
2050.
is the third. Yes.
Okay. Thank you. Yes. So we were talking about that, what we see in future and how we need to align our future. So on the right-hand side, we can see that tomorrow's operational baseline, that artificially grown hamburgers are already commercially available in Singapore and the US. Even if we talk about the chocolates from your 3D printers, they're already in production in confectionery supply chains. So how this is coming, how they are creating this in agriculture vision, that we need to know. And saltwater cucumbers that delivered by drone. Last mile delivery is being piloted across Asia, Europe, and Africa right now. My point is this, that every generation believes the next technology leap is a generation away, and our data tells a different story. The leap is happening now, and 2050, my dear friends, that the 2050 is the inflection point at which these technologies are going to shift from competitive advantage to the survival requirement. So, how many of you have seen lab-grown proteins on a menu? So that we should be well versed of that how many lab-grown protein is there. Whenever we see the menu, we go order in restaurants. So we need to know that whether it is actually grown into the land or it is a lab grown. So we can start identifying that what 2050 is going to be predictive. So the 2050 imperative. Now we have heard about a lot of geopolitics here. One thing is happening, another thing is happening, and automatically the scarcity would be there. So to understand that why we are here, we need to understand the pressure we are building towards. So firstly, I would like to state that 9 billion people by 2050, global population is going to project to reach or exceed 9 billion times. So this alone has elevated food security to the very top of the geopolitical agenda. So we need to really know that what geopolitical in actually is. And we are not just talking about hunger, but we are talking about the national stability. We are talking about the trade sovereignty, and even along with that, the conflict preventions. So that would be the first part. Coming over to our second part, that talks about the severe scarcity, or we can say arable land, fresh water, and we can even constitute with the fossil fuel, which would be the derived inputs, and all are reaching critical depletion trajectories these days because of this geopolitical agendas, the scarcity. So the margin for inefficiency is closing so fast now. We really need to buckle up and ask everyone that what about the maximum resource optimization? Because the maximum resource optimization is no longer an aspiration. It has become a mandate now. So talking about our third part, which talks about the socio-cultural shifts. So this is the driver that most policymakers underestimate. Changing dietary preferences, religious food requirements, urbanization, and the global rise of a plant-forward consumer culture. So these are the fundamentally altering both demand for food, we can say, and the systems that produce it. So together, these three focuses create the pressure that makes innovation a non-optional. So I have a question for everyone who are attending today, that which of these three do you think possesses the greatest risk in your region. So if you can just think about that, what would be the greatest risk in your region, your area, you would be able to identify it further. Moving ahead to our next part, the threefold innovation engine. So we need to understand what is the threefold innovation engine and how this framework really work. So now that we understand that the why terminology, let's talk about how, because why has been discussed. Now how? So future farming cannot just rely on a single point solution. What we need and what the evidences are supporting, that is a synchronized part. So we have a threefold innovation engine for that. Now, how threefold we'll say? Because it would be a combination of technological, economic, and social. So how technological? So this means that deploying the automated systems, or we can say smart materials and advanced manufacturing at scale. And the tools on the next several slides were live here. Second is the economic fold. This means restructuring value chains to minimize resource wastage and reduce the operational costs. Technology without economic redesign fails to scale. So that need to be economical. And the third is the social. This is often overlooked because adapting to new consumer demands, managing labor market transitions, and even building public acceptance of engineered food sources is a critical as the engineering itself. So these three gears must turn together because that is automatically at a threefold. So these needs to be turned equally and together. Only then we'll be able to understand that how these things work. And advance only one and the system stalls. So that is the core logic of the precision blueprint we need to discuss. Moving forward, now for this, how, why, now we need to know that what next generation manufacturing was, how 3D versus 4D printing came into life. So this is the technology deep diving. So let's move into the technologies themselves. First up, next generation food manufacturing. When we talk about agriculture, agriculture itself relates to the food, to any layman person. So most of you are familiar with 3D printings. In food, this means layer by layer additive manufacturing from a digital blueprint. The inputs are fine powders, vegetable materials, modified starches, protein concentrates. And what is the output? The output is precise, customizable, repeatable food structures, right? So static ones produce. So that is the 3D. And when we talk about or discuss about the 4D printing, so 4D printing is where it gets remarkable. It adds the time as the fourth dimension. The structures are built to evolve and the materials used have inbuilt pivoting and pressure points in that. Electronic components within the structure dynamically respond and change their shape. And now how they respond and change the shape? Under the influence of light, temperature, or we can say the moisture itself. So the question arises that what does this mean practically? So imagine any packaging that self-seals when it detects a breach, or we can say a food structure that releases some nutrients proactively based on your body temperature, or we can say some livestock feed pellets that expand only in the stomach, reducing waste. So that's why the comparison on this slide show you the precise mechanism difference, that it is not just about what you print, it is about what happens to the print after it is made. So that needs to be known. For example, is this commercially viable? That comes into the mind of many of the participants. So my answer for this is that 4D is in pilot stage. 3D is commercial. So be ready to cite Nestle, Barilla, and various hospital nutritional programs as current 3D adopter ones. So that is the point. Moving ahead to another one. So here we would be talking about our smart materials. Now, what are smart materials? How the autonomy really work? And how this intelligent packaging is done. So this is also a technology deep dive. So the second technology pillar is the smart materials, specifically their applications for food packaging. I want you all to look at this diagram carefully because it tells the story better than any supply chain report. For example, let's talk about this. The first factor that talks about the color indicating freshness sensors. So AI itself, the real-time visual data showing exactly that how fresh a product is, right? So AI is enabled in that. And no more guessing, no more labeled data date over caution, right? So this alone can cut household food waste by an estimated rate of 20 to 30%. Next is our autonomous temperature control. So how the autonomous temperature is getting controlled? So self-cooling, or we can say self-heating layers, which are embedded in the packaging. So this extends the cold chain without requiring the continuous refrigeration infrastructure. So we don't want that. They can do by their own. So that is a game changer for the markets in sub-Saharan Africa and the rural South Asia. Third, we'll talk about the ultra absorbing materials. So you see this image at the bottom right. So this is a nano engineered surface which is capable of instantly absorbing all oil based, or we can say toxic spills, and critically for hazardous material containment in processing the environments. So that is all already there in the market. And the fourth part is where we will talk about the ergonomic access. So what is that? In which the adaptive packaging specifically is designed for elderly consumers. Easier to open, but engineered to maintain the freshness seal. And this responds directly to the socio-cultural shift we discussed. Smart materials are not a luxury add-ons, but they are infrastructure for the next food economy. So that we need to think. Moving to next, the robotic labor force. Now, when we discuss about AI, ML, AI is artificial intelligence, ML is machine learning. We talk about drone, we talk about printings, right? How the food is being contained. Then we will definitely discuss about that, how the robotic labors are forced, how the automating the monotonous thing. So that we need to discuss. Let's talk about labor. So farming is inheritably labor intensive. Everyone requires so much of intense work in that. And also one of the most physically demanding, dangerous, and even poorly compensated sectors globally. The solution is not to eliminate the labor, but it is to redirect it. So how to direct it? That we need to know. So for redirecting, we have already first humanoid and grip arms. So these robots are designed to mimic the human appearance and behavior, specifically for complex physical manipulation tasks and harvesting the delicate produce, sorting by tactical quality, and even plus they can navigate the unstructured terrains. So what makes today's agriculture humanoid different from earlier industrial robots is their adaptability, that how they handle the variability that needs to be known. Second, we have the agricultural drones, which are unmanned flying systems operating at a scale for automated sowing. We can say planting, fertilizing, weeding, and even for the continuous crop monitoring. A single drone operator today can monitor and treat farmland equivalent to what previously required 40 to 50 workers. So that is the technology part. So by delegating repetitive and dangerous tasks to these autonomous systems, we achieve something important. So we free human agricultural workers for oversight, for quality control, we can say, even maintenance, and even we can see the judgment intensive decision machines cannot make. So this is not, people would be thinking that this is a job destruction, but no friends, this is not a job destruction. This is a labor intelligence. And even we can see in different sectors, regions, greatest labors come bottleneck in the food supply chain also. So that we need to think upon that how the things work ahead in our particular regions, our particular sectors. Now coming to our next part, that autonomous microbots. Now what are microbots and how the sub-millimeter engineering really work? So now we get to what I consider the most technically remarkable innovation in this portfolio, that is the autonomous microbots. And what is autonomous microbots? So these are independent kinetic machines which are capable of operating within the confined biological, we can say, or mechanical environments. They think like human blood vessels. If we can think how they work, so think agriculture irrigation pipelines, or either we can think of soil microstructure. So the engineering on this slide shows a modular microbot assembly, and inside we can see that a 2.5 mm pipe made of higher resistance alloy. And the key capabilities you are looking at is intentionally shape shifting. The microbot can rearrange. So here the microbot we have, so it can rearrange the connectivity of its constituent parts, that how to rearrange, how to work, how we need to really work upon. So that is a shape shifting. We can rearrange the connectivity, how I need to reconstitute my parts, so that he can do. And even it enters as one configuration. It moves through the pipe as a worm-like structure. It exists or deploys in another configuration entirely. So that is the thing. Then we'll talk about the core capability, which is confined space navigation with self-rearrangement. So they can do that as well. And unlike some conventional robots, there are no fixed joints. So the machine is its own adaptive infrastructure. Application in agriculture, how it is going to be applied? So how? So monitoring and maintaining extremely narrow irrigation infrastructures with exceptionally low energy costs. That would be the thing. It can detect the blockages. It can repair your micro fractures, delivering to targeted inputs directly to root zones, and at a precision level no human hand can reach. So that is the joy of this autonomous microbot. And this technology is early, but it is moving very fast. The defense and medical sectors are driving its development, and even agriculture is positioned to be a major beneficiary with this decade. Next now. So next generation conservation, how to extend the value chain. We have talked about production. Now let's talk about the preservation, because up to 40% of food produced globally is lost between harvest and consumption now these days. So that needs to be known. So this is an economic catastrophe and an environmental one. How? First is high pressure processing. by subjecting products to extreme pressure without heat, we inactivate the decay organisms, the pathogens, and even the enzymes. And cooled products stay fresh for over a month. No chemicals, no thermal degradation of the nutrients. Second, how to preserve? Through cold plasma. So in inert, some gases deployed at ultra low temperatures, we can say under 40 degree Celsius, to disinfect both packaging surfaces and the food itself, which would be effective against a broad spectrum of pathogens. Particularly powerful for fresh produce and ready to eat products. Third is the pulsed electric fields. So these are the targeted electrical disruptions which would be inactivate pathogens. Specifically, they are used in liquid food products such as juices. We can talk about dairy, liquid eggs, so that, and even the minimal thermal impact would be there and maximum pathogen control is there. The fourth positioning would be that how to preserve would be the microwave processing and genetics. In this, the advanced microwave processing to maintain the organoleptic quality that we need to see. For example, the taste, texture, aroma. So these three would be combined with the application of a anti-decay genetic modification. So this is the frontier where food science and biotechnology intersect together. So these are not only theoretical, we would say, but they are at various stages of commercial deployment today. So that we need to know. Next, the synthesis. Now, the agritech impact metrics we discussed. Now we have already covered the 5 technology domains. The question every strategist in this room should be asking is that where do I place my attention and resources? So my dear friends, this matrix answer the question that on one axis, the technologies could be, and on the other, the 4 critical dimensions we can put of agricultural value chain impact. For example, the cost reduction, the environmental impact, the resource optimization, and even the labor efficiency. Aerial drones deliver the clearest wins in resource optimization and the labor efficiencies. Microbots are the standout performer in cost reduction. Advanced conservation technologies lead in resource optimization alongside drones. Then we discussed about 3D, 4D printing. So 3D, 4D printings and smart materials offer the distributed impact across multiple dimensions. So the strategic takeaway, and I want you to hold this, is that no single technology solves every challenge. Strategic capital must be deployed where these capabilities are intersecting together and with most critical value chain bottlenecks. So we need to map our bottlenecks first, then we need to set our technology. Then that is the discipline this matrix is designed to enforce. So this would be the matrix for the strategic people who would be thinking about that how to go ahead with the technology plus our problems. Next, the innovators deployment blueprint. So we have built the case now. Now let's build the plan. The innovators deployment blueprint is a 4-step decision framework for translating today's insight into tomorrow's implementation. So first step would be we need to identify the node. Pinpoint that exact area in the agricultural value chain where the bottleneck or resource hemorrhage is occurring. Not a general problem, but a specific node we need to take. Harvest loss, cold chain failure, it could be input over application. So any particular node we need to find out, right? Now constraint of that problem. Narrow irrigation or microbots, spoilage in transit, smart materials plus high pressure processing. So that needs to be known, and even the labor shortage at harvest. So humanoid robots plus drones would be the thing. Step 3 would be the define the beneficiaries. So we need to clarify who benefits out of that. Is it the primary producer, the logistic manager, the end consumer? So we need to see, or we can say, different beneficiaries require different deployment designs and different success matrices. So that needs to be there. And step 4 would be quantify the impact. So before you deploy, project the measurable outcomes. That what would be the outcomes? What would be the labor cost? That needs to be known, and how it is moving ahead. So that could be the thing. And further, then we need to see even that how the things work in actually, how the technology has put in the efforts into that. So uh, back to the thing that project the measurable outcome. So labor cost reduction can be by X%, environmental impact mitigated by Y units, we can see. And what would be the resource optimization, whether it is improved by Z%. So that needs to be calculated. If we can say that if it is not being calculated properly, if you cannot quantify it before you start, you cannot claim the credit when it works. And you cannot quote the correct um, course when it doesn't. So this is a practical tool, and I encourage you to apply it to a real challenge in your organization before you leave this session. So that we quantified it, we measured it. And now we talk about that securing the 2050 biosphere. So let me leave you with this, that the tools required to sustain 9 billion people are no longer theoretical these days. They exist. They are being very refined, right? They are being deployed. And we need to understand that how the things really work. So we can say the question is not whether this transformation happens. It will, because transformation will happen automatically. The question is whether your organization, your policy framework, your innovation agenda is positioned to lead it or to be disrupted by it. So that we need to know. So by applying the precision blueprint, we can say advanced robotics, smart materials, and 4D manufacturing, we are transitioning agriculture from a game of chance into a system of absolute engineered resilience. So the 2050 biosphere is something we are engineering right now. Every decision you make in the next 5 years contribute to what the future looks like. So we need to start thinking that how these technologies would really work if we have small holder farmers in the developing markets, if the regulatory status of lab grown and 3D printed food. So that question needs to be there in our mind. We really need to think about these things. So that was a thought I have given to you all. You all can start thinking that how these things will really work. And that's all from my end for this. Thank you so much. Hello.
Yes, ma'am.
Yeah, I am done with my session.
Okay. So,
Yeah.
ma'am, I'll just do one thing. I'll enable chat box for all. If
Yes.
someone might be having queries, they can just drop down their questions right here. And if you want that, you can respond accordingly.
Yes, yes. I'll be taking care of the chat box. If
Okay.
anyone
Ma'am,
has any query, anything, yes.
yeah. Ma'am, I have just enabled the chat box, and I guess that most probably within 1 to 2 minutes we'll be addressing with the questions.
Sure.
Thank Ma'am, I guess we have received one query
Okay,
or a
okay.
question. Yeah.
So we have this question that talks about that smart packaging increases the product price. Yes, it increases the product price, and even the consumers who are using the smart products, they are ready to pay for those prices also. So that is a balanced belief.
One more, ma'am. Wait, I'll just dictate it to you. How can biotechnology improve the taste and nutritional value of 3D printed foods? And what are the major challenges in making 3D printed foods affordable for everyone?
Okay, so whenever we talk about that biotechnological foods, or if we talk about that how 3D printer is affordable, so it is not. But these days, if you can see, there are so many things in market already coming as the processed items, right? And it will not just give you a taste, but it has already generated such a system, or we can say the variation or the parameters when they created the taste. So they have taken the flavor molecules, so it will automatically enhance your taste of that. They have this enzyme tech, right? Because enzymes, they add in those printing presses, so the taste automatically start erupting. And even they have these cultural cells which are known as the lab grown fat cells, so that is there. So if we talk about the nutrition part, so automatically probiotics, bioactive components, so they are good bacterias. Yeah, omega-3 we can say, antioxidants. So already we are stabilizing them. Then they add into the print and then they provide you the things. And then we have that what are the major challenges in making 3D printed food affordable for everyone. So, you cannot say that it is that expensive, but we can say that printer plus ink cost, we can say food grade 3D printers, or we can say speed, we can say food safety and regulations like GMO, cultural cells, ingredients are there, and even they have these approvals from FSSAI, US FDA. So it takes the process costly and even the time consuming process. And plus, it's not affordable for everyone because we cannot compare the generations, right? Everyone has their own pocket value. One person can buy a chocolate of 10 rupees for a taste preference, and on the other hand, same person from same shop can buy a chocolate of 100 rupees. So it would not be affordable. It would depending on the quality and how we are margining it, right? So solution is nothing. Plus, if they need it to be affordable, then they need to have something, government support for the same thing. So that would be the thing for this. So even ma'am, if the prices vary, would it not create more difference in society? Automatically, if we talk about the organic products these days, and if we talk about the normal products, so there is a price difference in market. So society में differences तो पहले से ही हैं, right? No one is creating it. It all talk about that how the people having the paying capacity. One student is going to a small school, the other parent student is going to a bigger school. So the gap is already there. So we cannot compare the gaps. It always talk about that what premium we need to pay. So it depends on the capability of a person to person. There are many gaps in the society, and it is not possible that we can mitigate that particular difference of a society, right? Next question we have, okay, that robots can be used in agriculture, and is it possible nowadays? Yes, I talked about the humanoid hand. So people are already using in foreign countries. So that can be seen. So the answer is yes. Next, ma'am, can the smart technologies can decrease the nutritional value of food by 3D or 4D? So automatically there are many predicatives they are adding in the foods these days. Do we get the paneer? Earlier we used to get the paneer from the farmers, or we can say from pure cow cut milk. So no, already there the quality is depleting right now. Now if we need probiotics even, so how we get the probiotics? Yakult is a company who is offering us the probiotics. So we are infusing in our body through the alternative resources. So yes, that is the thing. But whereas if we talk about on the other hand side, that is it good to consume? So yes, it is good. Even we talk about so many of TV commercials, there are promoting on different whey proteins, right? My protein give you this, but the other is not giving. So we cannot do the comparison. Even you heard that after this COVID vaccination, so many cases came of getting the death signs because of people who are going more into gym. So they are getting the attacks. So it depends on what they have actually consumed. Moving to Dr. Angam. Yes, so is smart packaging used in India? How efficient is this packaging as far as India is concerned? Will it be successful in India, as India is the most developing country, unlike Western countries? India, we always talk about that India is the most developing country, and yes, from my childhood, I have been listening that only, that yes, still we are growing, we are developing. But no, I believe now they need to change this bookish language first. They need to really change this thing that no, we have already. And you asked that how smart packaging is used in India. So no, smart tech itself uh, has a very limited scale right here. So examples in India, if I talk about, so Amul, ITC, PepsiCo, so they have this time temperature indicators, or we can say the QR code traceability, oxygen observers. So they use those things. And if we talk about the efficiency, so fresh fruits these days, meat, dairy, so shelf life has automatically increased from 20 to 40%. So yes, they are using there in India. And will it get success in India? So yes, we are already getting success because already the companies are using this thing. So, but there are basically three challenges. Unless like other Western countries, the cost, the awareness, and the cold chains. Cost for normal packaging, say we can say 2 to 3% it is more expensive. And mass market के लिए ये सस्ता version we require because of seeing the Indian scenario. Second, we talk about the awareness. Many farmers, or we can say the store people, we need to make them also understand. We need to educate them also that how they need to reduce the wastage, right? Because they are not well versed of, they are not educated for the products. And the third thing is the cold chain, the challenge which would be there. So smart packaging plus cold storage, both we would be requiring, right? Next, we have question of Shweta Dasika that, hello ma'am, can 3D printed food reduce food waste and how? So yes, we have three different parameters for that also. First is the exact quantity, that whatever the amount we require, we should give instruction to the printer उतना ही, ठीक है? Because घर और रेस्टोरेंट में बची हुई सब्जी आटा वेस्ट नहीं होता है कभी भी, right? So that would be the first thing. Second, अगले ingredients जो use करते हैं, whatever the fruits we can say, what are the vegetables, उनके जो भी shape disrupt हो जाते हैं, ठीक है? So no one buys that. So to use, or we can say refabricate, उसका ही food paste बना के we convert the everything. And third is the on demand. It depends that what is the demand in market. So advanced may we can say that bulk cook no one does, right? So according to the orders, the print is done. So leftover is equivalent to the zero waste. And now we have one more question, that how, as we integrate intelligent packaging with swarms of microbots and precision problem, now evaluate these technologies within an AgTech impact matrix. So how I'll make you understand that we just need to add how to grow the more thing, how to go ahead into 2050. So we have to add 4 parameters in this economic, that what income, whatever the farmers are there, how the income or the cost is increasing. Basically, ROI में कितना difference है. Second would be the environmental parameter. It should talk about the whether we are reducing the less of pesticides, whether we are utilizing water properly, whether our soil is becoming more healthier, whether the how the carbon footprints are being calculated. So that would be second. Third would be the social, that how much my farmers are really technology savvy. Unko aata kitna hai, right? So that needs to be there. And the fourth part would be the resilience. That if there is any abundant land or if there is too much of rain, so how this technology needs to be properly worked upon. So that would, for this, the formula would be total impact. That would be yield gain plus the cost saved plus environment saved and the farmer skill gain. If we are working on this, then trust me, my friends, that it will increase by 50%. And technology never fails. We always upgrade technology, but technology never fails. Then we have what shall be a farmer's share and his payment. That depends on government and through chain to chain, who are the mitigators. And can AI-driven digital twins accurately predict the shelf life of perishable fruit under fluctuating humidity? Yes, automatically they do. They does. And then considering agri-tech impact metrics, which technology do you believe will have the greatest impact on global food security by 2050? That we already discussed here. And even if we talk about ChatGPT was a trend, then Cloudie was a trend. Now we have a Claw as a trend. So these will be upgrading. Is it possible to avoid quarantine measures? So if we talk about, for this, we have a different segment for quarantine measures. How can we manage complex nutritional component of that? We have already discussed, Neeru. On second or third slide, we discussed about the 3D and 4D printers and how the process does work and how the complex nutritional components really work and how it needs to be managed. I would be happy if there would be any other questions, so I would be taking that.
Ma'am, I guess we are almost done with the questions.
Okay, great, great. I would love to take more questions if there would have been. A few of them are repetitive, so rest were like good.
So, ma'am, now we'll be concluding the session.
Okay, great.
So, thank you very much, ma'am, for your insightful and inspiring session and your valuable perspectives on cultivating intelligence, how AI, smart skills, and advanced agri techniques are redefining the future of farming have greatly enriched our understanding and motivated all participants. So we sincerely appreciate your time, your expertise, and gracious presence at AGROVISION 2.0. So I once again, on behalf of Just Agriculture Education Group and all the participants of AGROVISION 2.0, that is our family of AGROVISION, I thank you for sharing your knowledge and experience with us. Thank you so much, ma'am.
Thank you so much. Thank you so much to AgriVision also. This is my second time I am with them. So I really like sharing new insights and all the best for your future endeavors.
Thank you so much, ma'am.
Yeah. Okay.
So as we conclude day 6 of AGROVISION 2.0, my heart filled with gratitude and inspiration. Today's sessions were truly enriching, from valuable technical insights to practical wisdom shared by our experts. The gracious presence and profound words have motivated everyone here. We are sincerely thankful for your valuable time and guidance. A big thank you to all our resource persons, organizers, and every participant from your active engagement and enthusiasm. Your energy keeps this program vibrant and meaningful. As we wrap up today's proceeding, let us carry forward the learnings and apply them in our fields, research, and endeavors. We look forward to welcoming you all tomorrow for day 7 with more exciting sessions, new perspectives, and continued learning. Until then, take care, stay inspired, and keep nurturing the spirit of innovation in agriculture. Thank you, everyone. We'll see you tomorrow for day 7. Jai Kisan, Jai Vigyan.